So the next section 8.2 is now going to start us talking about the similarity idea. So when we talk about things being similar, we mean that figures that have the same shape, but not necessarily the same size. So I always like to relate it to like if you go to the eye doctor and you can get your eyes dilated. And that always definitely, it's the same eyes, it's just obviously the shape of certain things changes. So again, the dilation or enlargement would be an example of something, and then the opposite of that would be something being reduced, like a reduction. So if it says, given the measurements shown in the diagram, find the height of the candle. So basically the distance from the candle to the object is 20, and the distance here would be 5. So those two have to go together. The height, which is what we're looking for, and then that would match with the 2. So we're continuing the goal of all this. The reason I taught the previous lesson is because it's all about proportions here. So we get 5 times h equals 40, which means h comes out to being 8 centimeters. So now, the most important thing in regards to similarity, when we talk about similar polygons, the ratios of the measures of corresponding sides are equal, okay? So it doesn't say the corresponding sides are equal, it says the ratio of the corresponding sides are equal. What is true, though, is that the angles are congruent. So there are two things. If you're trying to prove similarity, there are two notions that you have to touch on. One is in regards to the sides being proportional. 2 is that the angles are congruent to each other. So if you have these two triangles right here, we can see that the angles are all equal. So B equals E, A equals D, C equals F. But in terms of the sides, you right away, you're saying, okay, well, those numbers don't match. But again, it's not the idea that they are congruent, the sides, it's that they are in a same ratio. So I'm going to take each side. And again, the order is the same as you would do for congruent, so just make sure that you're labeling it correctly. So A to B would match with D to E, and that would get you 8 over 4, which reduces to 2 over 1. If we'd pick a different pair, B to C would go over here, and that what got me here. So that was 10 over 5, which reduces to 2 over 1. And the last pair here is AC over DF, which is 12 over 6, which again reduces to 2 over 1. So the angles are congruent right here. So we can say angles congruent, and you can say sides have the same ratio. So given that those two things are the case, you can then say the triangles are similar. Again, keep in mind order is important, but instead of now putting a congruent sign in between, the symbol for similar is the little tilde thing that goes above the equal sign in a congruent statement. So that's the new piece you're going to have to add. So this does not only apply to triangles, though. This would go to any shape. So if you have A, B, C, D similar to E, F, G, H, so you already know they're similar. We're going to find the missing sides, F, G, G, H, and E, H. So they already tell us we're similar, which means we know the angles are congruent. But in terms of sides, that's not going to help us. So what we want to do is we want to figure out, okay, well, what two sides match up that I have? Well, if I look, I have EF over here, and E to F is the first and the second, so that matches up over here with A to B. So those I have for sure. So 6 over 9 or 2 over 3, that's going to be my common ratio that I'm going to use throughout the whole thing. So the reason I need to know what that common ratio is because now it allows me to set up proportions to solve. So got my common ratio of 2 over 3. So now what I'm going to do is that 2 over 3 is going to be consistent throughout all 3 of my proportions that I'm now going to use to solve for my 3 missing sides. So now I just, again, who matches up with who? So if I want to get FG, well, FG is the second and the third letter, and that matches with BC. So that would be 4 over FG. That's my first proportion. Cross multiply and divide, I get 6. For GH, well, GH, if I use colors right here, GH is going to match with this guy right here. So I have 3 over GH, and I get 4.5 when I solve that. And then in terms of EH, EH is going to match with AD. So I have 7 over EH, and that's going to get me 10.5. But again, the consistent piece was that 2/3 that we had there. Now, when you're asked to find the ratio of the perimeters of your figures, okay, well, we have all the sides for A, B, C, D, so I'm going to add them up. I get 20. I now have all the sides to E, F, G, H, which gets me 30. And if I want the ratio of the perimeter, it's telling me the order, so I want A, B, C, D over E, F, G, H. So make sure you're writing it correctly, and you get 20 over 30, which the zeros cancel, and you end up with 2/3, which is funny because that's the same as the ratio of the sides. So this now lends us into Theorem 61 that says that the ratio of the perimeters of two similar polygons equals the ratio of any pair of corresponding sides. So if the ratio of the sides is 2 over 3, then you know the ratio of the perimeters is going to be the same. And vice versa, basically. All right, so where the next example now leads us. So it says, given we have two triangles that are similar, H is 90, J is 40, M is X plus 5, and O is 1/2 Y. Find X and Y. So if we know they're similar in terms of angles, I know the angles are equal. So J would be equal to P. H is equal to O. And then K would be equal to M. Okay, so if this angle is 90 and this one is 40, I know that 90 plus 40 plus K has to equal 180, which means K has to be 50. So that piece I know. I also know that K and M have to be equal, so I'm going to set those two equal, so I get X to be 45. There's my first part. And if I know that H is equal to 90, O also has to equal 90, so I'm going to set 90 equal to the 1/2 Y, and that gets me 180 for that one. All right, let's look at the last one here. So it says, given they're similar, so we know they're similar to each other, if I want, let's see, maybe I can add some congruent marks here. So BT matches with DT. Angle A, I know, goes with angle O right here. T would go with T. 1, 2, 3, just so I have some marks on here in terms of who's equal to who. It's just helpful. And then I have OT is 15, BT is 12, TD is 9. And I want to find the value of X, which is AO. So I can set myself up a proportion. So I've got AT, which is the whole entire thing. Well, from A to T, that should match with O to T. And then the two that I have BT, and BT matches with DT, and I have those as well.